This video you are going to learn about resistivity. In the previous video you have seen that if we have a conductor of length L and cross section area A, then the resistance offered by this conductor to the flow of charges is R is proportional to length and inversely proportional to area. So resistance R is equals to rho L upon A, where rho is equals to R, A upon L. This quantity is said to be resistivity or specific resistance. Why this is known as specific resistance? Because this is constant for different material. Resistivity of gold is different than resistivity of silver, which is different than resistivity of copper, different than resistivity of aluminum. So as you changes the material, resistivity also changes. So it is known as specific resistance. Resistivity does not depend on area and length. It does not depend. This is the equation only. Later on you will see resistivity depends on which quantity. Now how we will define resistivity? So here if we put area equals to 1 meter square and length equals to 1 meter, then what will be rho? Rho equals to R into 1 upon 1, this is equals to R. So resistivity is the resistance offered by a conductor of unit length and unit cross section area. What is resistivity? Resistivity is the resistance offered by unit length and unit cross section area. We can define it in another way also. For defining in another way, what we'll do, we will take a cube. Suppose you take a cube. Here it is a cube. Let us take a cube. Now in this cube, this is suppose current is entering from this side, this phase, and current is leaving from this phase. This means that this is phase 1 and this is phase 2. Current is entering from phase 1, leaving from phase 2. And the area of this is area equals to 1 meter square if the length, breadth and heights are 1 meter. Now in this situation, how will you define resistivity? Resistivity is the resistance offered by a cube of unit edge when current entered from one phase and leave from opposite phase normally to the area. It is said to be resistivity. Now you are going to understand about the unit of resistivity. Here the unit of R is ohm and the unit of A is meter square, the unit of L is meter. So you have ohm meter. Resistivity SI unit is ohm meter. Ohm meter is the SI unit of resistivity. Now suppose I am giving you a question. Question is a question. Number 1. Suppose you have a wire of length 1 meter. This is a wire of length 1 meter. And cross section area is A. Stretch the wire twice its length. We stretch the wire twice its length. This means that L dash equals to 2 meter. Now cross section area changes. Here the area changes. Now the question is, what will be the new resistivity and new resistance? What will be the new resistivity and new resistance? Very simple. Resistivity depends on material. So resistivity is a material dependent quantity. So there is no change in resistivity. Old resistivity and new resistivity both are same, but resistance changes. Now let us see how resistance changes. We know the formula, resistance R equals to rho L upon A. So resistance R is equals to rho, we can write like this, L into L upon A into L. We multiply numerator and denominator by L. So what we get? We get rho L square upon volume, VOL, volume. Now resistance equals to rho L square by volume. Now new resistive resistance R dash is equals to rho L is twice, so it is 2L. Volume is same, so this becomes 4 rho L square upon volume. So this is equals to 4R. What you have learned? You have learned that if resistance of a wire is R and the wire is stretched to twice its length, then resistivity becomes 4 times. Thank you.